Assalamualaikum warahmatullahi wabarakatuh.
Ni hao.
வணக்கம்.
My name is Siti Nushairah binti Abu Bakar and the metric number is CE190222.
My name is Nurswana binti Rosli. My matrix number CE190238.
My name is Nirwin, son of Manakal. My metric number is CE190241.
Firstly, we assume a random open loop transfer function S GS equal to 2.45 over S multiplied by 1 plus 0.05 S and multiplied by 1 plus 0.1 S. Then, both plot diagram for magnitude plot and phase plot using hand. GS equal to 2.45 over S multiplied by 1 plus 0.05 S and multiplied by 1 plus 0.1 S. Then we expand the denominator and we get the answer is GS equal to 490 over S multiplied by S plus 10 and multiplied by S plus 20. Replace S equal to J omega into the equation GS. So the equation is like J omega equal to 490 over J omega multiplied by J omega plus 10 and multiplied by J omega plus 20. To calculate the magnitude of J omega is modulus of G equal to 490 over omega square root omega power of 2 plus 100 and square root omega power of 2 plus 400.
Hello. Thank you Anishaira for the explanation. I will continue this manual calculation explanation. So from the magnitude value that we get, we convert it in units of decibel, which for both plot we use 20 log 10 G decibel. Then to find out the phase of G, so the phase of G is working with the transfer function. Alright, look at 490 and it phase angle is negative 90 minus with the phase angle of omega square root of omega power of 2 plus 100, which would be the inverse tangent of omega over 10 minus the phase angle of square root of omega power of 2 plus 400, which we get inverse tangent omega over 20 degree. Okay, now we calculate the value of magnitude G and phase angle of G for the different value of omega. Then based on this table, the magnitude of G decibel, we get after the magnitude G formed by insert the omega of equation of magnitude. Next, the phase angle of G get when the omega was replaced on equation of phase calculation just now. So based on this graph that we have drawn, show the output of magnitude shift, which is corresponding of the board plot from the manual calculation that we have done. Then the second graph in the phase shift graph, which represented the output of the phase calculation from the table above. Okay, that's all for me. Thank you.
Hey everyone, today I will explain about my team's simulation file. So let's see the coding step by step. So at first line, SYMS. What's the meaning of that? SYMS, the function to create a variable dynamic. Let's see at our command, which is SMS as creates the symbolic variable S and automatically assign it to a MATLAB variable with the same name. So let's see the second num. What is num? Num is the numerator of the function. How I get the 490? I get it from my manual calculation. So step number 3, 10. 10 is a denominator of the function. 1 equal to S cube, 30 equal to S square, 200 equal to S, and 0 is nothing. So let's see the next. What is TF? TF is a transfer function model that creates objects that representing continuous time and discrete time function in polynomial form. What is G? G is a transfer function model object which is a data container for representing transfer function in polynomial form. Let's see the last part. What is margin? Margin is a function to plot the bot response of the G on the graph and indicate the gain and phase margin on the plot. So let's see my output. This is my output graph, which is similar to my manual calculation. From the simulation, we can see that the gain margin is 21.8, which is at 14.1 radius over s, and also phase margin is 69.9 degree, which is at 2.37 radius at over s. Okay, let's see my output. Okay. This is the value which is calculated by method. The transfer function that this is my transfer function for and g equal to 490 over s cube plus 30 s square plus 200 s, and my gain margin is 12.2449 and my phase margin is 69.9290. Beside that, we also can see that WGC is a frequency that gain margin is measured, which is a negative 180 degree Celsius phase closing frequency, and also WPC is a frequency where the phase margin is measured, which is a 0 dB gain closing frequency. So from the simulation, we can know that my 14.1421 is the VGC and also 2.3676 is my WPC. That's all. Thank you.